Tonight, folks, we are going to be talking about protein and obviously how protein intake can be very useful. Turns out lean mass is pretty important for a lot of sports. And we're going to learn about some, a couple caveats of what we were trying to do if we're trying to optimize and just kind of get some basic, best practices. Feel free to ask any questions. We're going to talk a little bit about different protein sources at one point and kind of parse through effectively their efficacy, if you will. So effectively, the graph on the right is giving us information of where each of the individual amino acids are going to feed into being broken down metabolically. So we can see where we have our different types of amino acids that can be converted into pyruvate, which means they can go through gluconeogenesis. Those that can be converted into acetyl-CoA and also acetoacetate, remember that's ketone body. And those that are going to be intermediaries in one step or another of the Krebs cycle. Now, one thing that is fascinating is notice you see phenylalanine and tyrosine more than once, because it turns out, depending on how you lyse it or break it down, you can actually utilize it for different fuel sources. So now remember, amino acids, that's the most basic building block of individual proteins. We're obviously going to combine them into different configurations, meaning linkages of chains of them that are going to have different effects on folding, which is going to give us differing physiological functions. Now, we're going to transport them into the body, usually through that wonderful sodium sym port we talked about earlier. Sometimes we need to use some ATP. We're going to break them down and interconvert them, and we're going to talk about that interconversion a little bit. That's going to be where we have our non-essential amino acids that we can convert into them from our essential amino acids. Now, protein breakdown, it turns out all of our proteins in our body at some point are going to break down. They need to be replaced. Goes through an ubiquitin protease pathway that's in turn going to go ahead and bring it down to its basic amino acids. We'll synthesize them where we can. And once again, that is going to be our non-essential amino acids. We're breaking them into or building them into complete proteins and other compounds. So right here, we have a couple simple products that are made from a few amino acids. So things like creatine, glutathione, which is a major antioxidant in the body, the different neurotransmitters. We're going to see tryptophan for things. Tryptophan is going to be pretty important for dopamine. For dopamine, and actually going to be a component that's also, that's going to be important for serotonin. Tyrosine is going to be important for epinephrine, norepinephrine, as well as some others. And then our purines and pyrimidines, that's going to be those two components of our DNA bases. So our essentially cysteine, guanine, thiamine, and adenine. So what we have here, guys, is a typical protein turnover in the human body in a given day. So we're saying there's about 90 grams that we're going to take in from the foods we eat. 70 grams is being essentially secreted. This is literally our body creating those different enzymes that are breaking down proteins. So all those, and fats and carbohydrates. We then have obviously a certain amount that's just going to go out and be wasted in the feces. About 150 grams is going to be absorbed. Okay, so we've got a 10-gram loss initially. Now, about half of that is going to be lost, turns out, from just the general of essentially urine. So it's going to be in the form of ammonia, urea, uric acid, and also creatinine. Not the same as creatine. Those are two very different components. Now, when it comes to protein synthesis, the majority of it is actually going through things like our gut, lung, liver, brain, all of our other tissues. Then, yes, we do have a certain amount that's going into muscle for turnover. And obviously, we are going to need a certain amount every single day to build more red blood cells and both build and keep going our white blood cells, as well as, remember, we're constantly secreting albumin. So, questions over the basics of amino acids? Nope. Okay. Now, obviously, as they're broken down, sometimes utilized as a fuel source, but it's a very small amount that we're going to talk about in a bit. The amino group itself has to be removed, meaning the nitrogen, okay, the amine. Now, as this is being removed, okay, we in turn are going to create that keto acid, which is going to in turn create another amino acid. So this is going to be transamination. So we take the amino on one, slap it on the other. We're fine. The other is where we're going to remove it and create free ammonia. Now, this is oxidative deamination. Obviously, we're needing oxygen to do so. And once we go ahead and have that ammonia there, it's pretty toxic. So we're going to metabolize that out immediately. And specifically, that ammonia, or the ammonia group effectively, is going to be incorporated into glutamine or glutamate. Okay. So we're starting off with literally alanine or pyruvate from, when you think about normal metabolism, and giving those amine groups, we in turn are going to create those amino acids. Now, from there, we can transport it also around to the liver, where it'll be converted into urea. Urea in turn is going to go to the kidneys. And from there, we're going to obviously remove it. Now, we do lose a certain amount in sweat, and that's part of the wonderful stain and the smell that comes with it when you happen to be sweating a lot. And on an unrelated term, it would be a mild component whenever you have something that people refer to as the meat sweats. That's mostly due to the thermic effect of food, not that you're actually sweating out ammonia, but I thought it was kind of fun to bring up. Now, our body is constantly breaking everything down and building it back up. We refer to this as protein turnover. So certain things are happening really quickly, certain things are happening really slowly. So when we think about things like enzymes, hormones, those are going to be turning over really fast. Whereas when we think about things like our connective tissues, our muscles, those are going to be turning over pretty slowly. We're talking about days, weeks, months, especially when we're talking about things that have really, really poor blood flow, like our tendons and our ligaments. That timeline is going to be more of in the months. So literally, do any of you guys have an idea of effectively how old the oldest cell in your body is? Take a wild guess. How old do you think the oldest cell in your body is? Not bad, Colleen, not bad. Older than that, younger than that, Tyler. And actually, Paige, it's on air, it's about 7 years. That's the oldest cell. Your cells are just a copy of a copy. One of them dies, one of them goes on, copy of a copy, one of them dies, one of them goes on. And, you know, you go through the apoptosis, depending on when you define it, the programmed cell death. Now, what this means is we're constantly having to remodel and rebuild every single thing in your body. And obviously, it's one of the things that if we're doing this remodeling and we're trying to rebuild a tissue, well, it's going to be based upon how quickly we have this turnover. Now, certain tissues have really, really rapid turnover. So when you think about your GI, that's got a really fast turnover. When we think of things like your tendons, that's really slow. And that's why it turns out, you know, you can have a bit of a injury to your GI or otherwise, you can have a bad sunburn otherwise, and it's going to fix itself pretty quickly. Whereas if you have like a really bad tendon injury, it gives you tendonitis, it can be something that plagues you for quite some time. Now, this turnover is going to be based upon the amount of protein we're taking in to how much we have as losses every single day. If we're taking in more than we're giving off, this gives us what's known as a positive nitrogen balance. We're accruing protein, which is typically related to accruing lean mass. Whereas if we happen to be not taking in as much protein as we're turning over a day, we're going to be in a negative nitrogen balance, which typically means we're losing some form of lean mass. Now, the reason we care about this is, once again, the balance between synthesis and degradation, okay? We want to make sure that we're in balance, we're not losing or gaining lean mass. If not, we on occasion want to be in a positive nitrogen balance. So that means we're accruing lean mass over time. Now, this is going to be something that is important when we're looking at our total dietary intake. Now, what's fascinating is since we're constantly trying to recycle the same amino acids, that's why even though our protein turnover is a much higher degree of grams per day, it's by no means all just the protein you're taking in. Yeah, that would be part of it. The other part is you just shoved a metal spike through something in your body for aesthetics, which I don't understand why people do that, but I'm not obviously in that demographic. Now, we talk about breaking down those amino acids, guys. Here's going to be those conversions when you think about the individual amino acid, individual enzymes that are important, and effectively what's going to be our final product that we're going to have as we're going on through, as well as we can see kind of more of a conversion map of where you can see the interconversion and switching from one to another, depending on what is going to be our overarching goal for which amino acid we need. Remember, these are going to be ones that, well, a number of these, if you guys notice, are going to be effectively intermediates of things like the citric acid cycle. Others are going to be potential energy sources. And then obviously we can change into different amino acids. Now, since we care about how much protein we have turnover, we have a number of different methodologies at our availability. Different costs, benefits, issues, positives with what effectively we're doing. We can literally look at how much is in urine and sweat. That requires collecting urine and sweat, how much fun that is, but it gives us an idea effectively how much protein through urea and ammonia that they happen to be essentially removing each day. 3-methylhistidine is going to be something where we're looking at essentially our muscle protein breakdown. This is a metabolite that we're going to be able to see. It doesn't actually give us an idea of how much muscle we're building so much as how much damage we're getting. Now, nitrogen balance is great if we can really know exactly how much someone's taking in, as well as know how much that someone's losing, but it's going to be something that's relatively difficult. Arterial to venous measurements, so we're looking at the difference across tissues. This can be useful because it'll figure out effectively how much we're taking in and giving off. However, it's very invasive because you obviously have to take the measurements from the arterial side and the venous side, as well as it's not going to be the most consistent, easier way to do it. Radioactive labeled isotopes, you can actually see how much is taken up and giving away. It requires putting something radioactive in a human body. Not always a great choice. Stable isotopes are going to be things you're going to be able to measure just on the weight of molecular. It's pretty expensive to go ahead and do, but obviously you don't have the same health risks. Other tracers that are going to bind to this can be useful, but at the same time, we're going to have to do muscle biopsies to figure out how much was incorporated. And same thing, pretty expensive. You have to do Western blotting so you can go and see it. And then fractional synthesis rate is along those same lines of now we're effectively looking at the turnover we're having in those areas. End of the day, guys, what would be the cheap way that you would try to go ahead and track essentially nitrogen balance? And really, when we're talking about nitrogen balance, the proxy we're going to care more about is going to be changes in lean mass. So how would you guys try to go about that? No worries, Paige. What's a cheap way that you guys would actually try to essentially track someone's protein turnover? So how much amino acids are really chewing through and going through on a daily basis? Now, food log is going to give you the inputs, but what outputs are you going to measure? You're on the right track, Colleen. Now, that's going to be useful. Calories in, calories out are a great metric when we're looking at, obviously, overall body weight changes. However, we can gain lean mass while we're losing fat mass. Very difficult to do. Some more novice people are going to be better at it than others. Just like we can potentially lose fat mass while we're gaining overall body weight, so gaining even more lean mass. Pretty difficult to do, very possible. What's going to be the end all that we're really looking at here? What would we really want to measure? Exactly. We should measure body count. We're using the same method each time. Talked about this in XFIS, and obviously learned it in other classes. If we're being consistent, meaning we're being reliable using the same testing methods, we can get an idea of what's really going on with the overall average lean mass changes. So are they accruing or are they losing lean mass on a day-by-day, week-by-week basis? Now, when we happen to be going through and working with athletes, we do have some ideas of effectively how much protein we want them to take in. It's relatively simple when we're looking at these ranges. If you just want it quick and easy, it ends up being about 1.2 to 1.5 grams per kg for an endurance athlete. For strength athletes, it can be higher. Now, if you've got an athlete that's doing insanely high volumes of work and is trying to get leaner, specifically we're talking about bodybuilders and otherwise, that's where you see this massive, massive uptick in how much protein we'd want them to be taking in per kilogram of body mass per day. Now, there's other recommendations that you can do that are based upon the athlete's actual overall effective lean mass they already have. So giving that 1 gram of protein per pound of lean mass is a good way to go about it as well. Because if you're dealing with a 400-pound person, they don't need to be taking in 400 grams of protein per day, because we're trying to stick with more of these recommendations for maintaining lean mass. They have a lot of fat mass, so we can base it off their lean mass instead. Now, what we have here is a before training and then while during training, and you can see how this nitrogen balance is going to shift. So you're seeing how these individuals in their training days, they're not getting in probably the adequate protein that we're looking for. Now, this right here is an example of the switch between overall average protein synthesis and overall protein breakdown, protein degradation. Now, training is going to allow us to have an accrual. Now, notice each of these boluses is a certain amount of protein with each of these times. If we're training, we're going to have an even greater amount of synthesis after that training bout to allow for greater lean mass accrual. Now, the reason we care about this is it turns out if you're trying to build muscle mass, we want to be feeding athletes enough, and we're going to get into some of the better approaches later on, that we're going to be optimizing that lean mass change. Now, we're going to see that some folks are going to be at a risk for not enough protein intake. First and foremost is obviously, if you're not taking enough protein, you're going to lose lean mass. The body's going to prioritize your heart and your nervous system. So you're going to be losing some of that lean mass from your muscle mass, as well as you're not going to be recovering very well with all of your other tissues. Now, athletes that happen to be in weight class sports can have issues with not taking in enough protein simply because they can just not be taking enough calories anyways. It's obviously going to be hard on the body. If we're really going hard to make weight at the very end, we should still try to keep protein up and then taking at least enough carbohydrates so we don't get loopy. But certain situations are going to require you to do things that are not optimal, much less healthy. And let's not even make jokes, or let's not even try to make it sound like there's some in between there. Now, some athletes can have issues specifically on their style of eating, specifically vegetarian athletes. It is easy. It's not incredibly difficult to get in enough protein if you happen to be on a vegetarian or vegan diet, as long as you're making appropriate food choices. The key is, like anything else, if we want to be a vegetarian, so no more meat, dairy, etc., what is something we could do to effectively get in plenty of calories, but we're never going to get in enough protein? What can we just eat a lot of? Yeah, junk food. Haley, pasta. Actually, the funny thing is grains, depending on the source, can actually have not a huge amount of protein, but a little bit. But yeah, if they're just doing straight up processed junk food and they're essentially doing nothing but rice and they don't even doing beans, they're not doing nuts or otherwise, we can start to see a bit more of this potential issue. Okay, like anything else, we're tracking our athletes. We're looking to see how their lean mass is changing. We're looking to see how well they're recovering. Are they getting stronger? Are they getting weaker? Are their times improving? Are their skills improving? Or are they sliding backwards? Now, you do use a small amount of protein as an energy source. Notice, guys, less than 15% when we're at rest. When we're exercising, it's going to be maybe 5%. Most of the fuel that we're getting is thanks to carbs and fats. So we're not really taking in protein as a fuel source. It is fascinating where it seems like we do break down a little bit more, specifically leucine, isoleucine, and valine are branch chain amino acids when we happen to be doing very, very long exercise. However, we're not thinking of protein whatsoever as important for performance during. It's important for recovery so we can increase subsequent performances. So when it comes to our training approaches that we're using, certain individuals are going to have a greater amount of protein turnover. What we have here essentially is the signaling pathways that are going to be important to actually increase lean mass or decrease lean mass. Now, if we're doing strength training, we are going to get the activation of, it's the insulin-like growth factor 1, which in turn is going to activate phosphoinositol 3 kinase, which it's going to in turn activate AKT, used to be known as protein kinase B, which in turn is going to activate tumor sclerotic proteins 1 and 2, which in turn is going to cause mTOR to become activated. And it's going to probably be, it's in the Raptor, not Richter, which in turn is going to phosphorylate P70S6 kinase, which in turn is going to activate S6 kinase, which allows ribosomal protein 6 to work, as well as eukaryotic initiating binding protein 4E to be phosphorylated. So it allows eukaryotic initiating factor 4E to work also on your DNA. I have a PhD in this area. You do not need to worry. Oh, FOXO and MRF-BOX are actually going to be apoptotic pathways. So essentially shutting it down so your cells don't just eat themselves. Whereas on the other side, through a lot of energy use, we're going to activate AMP kinase, which in turn is going to inhibit muscle gain. So this is why it's important when we're looking at total calorie intake, total fuel levels in the body. If we're doing a lot of aerobic style training, we're going to be inhibiting greater muscle mass. However, we're activating PGC1 alpha, all of these different essentially signaling pathways we are going to get to in greater depth later. I'm introducing them. At the end of the day, guys, a signaling cascade is nothing more than a number of dominoes that have to topple over. So effectively, when we activate these pathways in turn, we're going to be able to either cause muscle gain, if we're looking at the gray, or cause, notice, increasing the amount of mitochondria, but we're not going to be really increasing our muscle mass. Okay. Now, who's got questions, guys? I just kind of went through stuff that's pretty heady. The key factors, it's going to be mTOR, AMP kinase, and PGC1 alpha. And we're going to come back to this again later. But here's the thing. How we build muscle is not magic. It's not witchcraft. It's just a pathway that becomes activated, which in turn activates another protein, which activates some proteins, inhibits other, that's G6 kinase. And from there, it's going to cause either us to synthesize protein or for us to break down protein, that's the MRF-BOX, or increasing the amount of mitochondria, okay, depending on what type of stimuli we're applying to the muscle. Key thing is, we're going to have demands for something. We need to make sure we're matching them. So when it comes to protein intake, there's also more recent work from Norton. I've got the reference to the Schoenfeld work here, which is we want to be taking protein boluses in throughout the day, okay? This allows us to be in a greater period of time when we are effectively in synthesis. If you want to do a protein meal pre-dinner or pre-bed, that can definitely be useful as another way to enhance lean mass. Usually they can go as high as something like 0.6 grams per kilogram of body mass, literally right before you go to bed, in order so you're going to be able to maximize that protein synthesis while you're sleeping. Now, we don't want to do just one giant bolus. We want to divide this up throughout the day, usually in what seems to be about a minimum of about 20 grams, could be as high as 40, and it trends up, obviously, if we have a bigger body when it comes to protein. We don't want to do just one giant protein meal, much less do we want to be sipping on amino acids all day long. Because if we don't get over a certain threshold, meaning if we're only taking 2 or 3 grams of protein at a time, we never actually spike blood protein levels, and in turn, it's never going to really help us. So we want to do these pulses throughout the day of 20 or more grams, depending on body size. Does that make sense to you guys? Good. Now, the other component is if we're taking in protein with carbs, it's going to
a quick question. I'm sorry. It takes a second to type. So, how does this concept apply to people who eat like a bunch of small meals throughout the day, opposed from like eating the standard like 3 meals per day?
Awesome. it's a curvilinear relationship. Once you get up to about 6 meals per day, you're not really gaining anything else. You want the spikes on occasion. Now, the key thing is, are we talking about the diet for someone who just, that's what they enjoy? Or are we talking for someone that's trying to get swole AF and recover as much as possible for their training? If we're talking about the latter, this is where we want to probably do 4 to maybe up to 6 protein rich meals, which we're going to talk about how they're also going to need a decent bolus of leucine in there as well in a little bit, so that we're going to be able to get the greatest amount of anabolism in their tissues. Now, if someone is living a lifestyle and obviously fueling themselves appropriately, they feel good, they work good, they're doing everything else in their life that they want to, they have the quality of life that they are looking for, let it go. Let them run their race, have fun. But we want to make sure that if we're trying to really optimize an athlete, which is the lens that we're using quite frequently here, we want to make sure that we're taking in things we need. Sodium, because if you guys remember the amino acid transporter being a symporter, sodium helps a little bit with that. Maybe some other nutrients, but definitely carbohydrate, when it comes to maximizing lean mass changes. So we can see if we're only given a limited amount of carbohydrate, given a limited amount of amino acids, we don't get anywhere near as much as that's phenylalanine uptake. One of our essential amino acids is much larger when we have a combination of the two. Now, if you're taking in 40 grams of protein or more, you don't need the extra carbs. You've already peaked yourself out. But carbs and protein taken in together is important because also remember, we're going to be replenishing muscle glycogen. So we're going to be able to do high intensity training again more frequently. So it's very important that we're trying to get in our protein in our immediately post-exercise window. Now, what we find that's fascinating is you can also take in the protein pre-workout, and the same thing we can take it in post-workout. Remember, there's always going to be that delay effectively between when you drink it and when it gets inside of your bloodstream. So if you're going to drink a protein shake while you're lifting weights, that's fine. As long as it doesn't cause you to vomit or otherwise, go for it. But if you're gonna be working out at too high of an intensity, you don't need it, that type of food, it's hard on your stomach, feels heavy in your GI. The idea is you can go ahead and ingest it immediately after or at the end of your resistance training, or even at the end of your aerobic training, especially when we're adding in some carbohydrate with it. So what you're going to see is, in general, we get a peak out of effectively how much fractional synthesis rate, so that's how much we're actually going to increase our muscle gain, is going to be related to, notice guys, the size of the muscle mass. So if we're doing something that's hard lower body, we might be talking about a 40-gram bolus. If we're talking about smaller muscle mass, lower body, you see how you get a little bit more out of 40 grams than you did 20, but you get way more out of 20 than you did 10, way more out of 10 than you did 5, and obviously way more than you got out of nothing. So taking in essentially a decent amount of protein in boluses throughout the day tends to be better. So specifically whey, something that's going to be relatively fast absorbing. We're going to find that if you're doing it in those 20-gram boluses, you're going to get more out of it than if you just did 2 40-gram boluses, much less 8 10s. So hence, once again, pulsing that protein intake throughout the day, because like anything else, once we go ahead and get a certain level of protein levels, we're just going to be breaking them down for fuel, okay? Which once again, still not a real major constituent. And then if we don't have it enough, well, that's equivalent of saying we don't have enough effectively of the prerequisites to build muscle that we'd like to. So as far as using amino acids as ergogenic aids, doesn't really work either. But branched chain amino acids give people flavored water, and some folks are really into that. However, we're going to give you guys your first little group activity that we're going to work on tonight, which is we're going to talk about different sources of protein that you can go with. Okay. So effectively, what I want you guys to do as a group, okay. Now, group 1, you are going to go ahead and talk about collagen protein, which beef bone broth is going to be one of kind of the things you see from it, or it's going to be one of the forms you'll find collagen protein in. Why collagen protein might be advantageous? Does it have a really good, okay, sorry. What will this be useful for? What dosages do you need? What sources does this come from? Okay. Those are the 3 questions that I want you guys to answer. Group 1, you guys are going to be doing collagen protein, so beef bone broth being a version. Group 2, you guys are going to be talking about the difference between whey and casein protein. They're both milk-based proteins, but kind of where and how you might use them. Group 3, you're going to go ahead and look at egg protein. So it can be egg whites, can be whole egg protein. And then group 4, I want you guys to break down any type of vegetable-based protein you can come to. And soy is going to be the one you see the most of, but effectively, when we would try to dose this, is have a good amount of leucine, how much of it are we taking, what are some potential pros and cons, and then, I mean, yes, you can figure out the source of hemp. We know where it comes from, but explain to us essentially how they refine it and get you that protein source. Questions before we put you guys in groups? Well, since I don't hear anything from you guys, the groups are now open. Go ahead and hop on in, have some fun. It's 6:31. We'll plan on coming back about 6:36, but be ready to answer each of those questions and putting that in the chat. Were you having issues?
And help maintain lean body mass. If like you want to help include it in weight loss, it helps you feel like fuller for longer.
Yeah. Good. So the key thing to parse between the two, great job, Colleen, is the fact that whey protein is much more rapidly digested. Casein is more of a slow digesting protein. So casein can be a good choice to take kind of that pre-bed or in between meals. Whey is a great post-exercise form because it is one that you rapidly assimilate. And it's much simpler, so it's also easier on most people's GI. Some folks have issues with casein just because it naturally, literally clumps up while you're trying to digest it, which makes it harder on the GI, which is part of the reason why you break it down at a slow rate. Now, absolutely. Good job, Sierra, specifically when it comes to collagen. Yeah, you're looking at, notice it's going to be up to a 15-gram bowl, so that's going to be relatively large. The key is it's essentially collagen is the connective tissue of an animal. It's really what it is. So things like Jello have collagen protein powder in there from the gelatin, which is going to be why you see beef bone broth and other sources along those lines. So it can be a useful thing. Sometimes we're looking at potentially recovery from tendinous issues, but it's not going to be as great as it might be overblown by some folks. Now, Tyler, for your group, Tyler, which group were you guys in? You guys were supposed to look at egg protein. How does, no, that's okay. That's okay. So egg protein, like anything else, is a complete protein. That's why you have bodybuilders doing sad egg white omelets, because it turns out, yes, you've got protein in there, as well as if you're doing the yolk, you're also getting cholesterol and a number of vitamins and minerals. So it is a good source. It is a complete protein that's very bioavailable. However, like anything else, it cannot, whey is naturally sweet, so it's a little bit easier to take as opposed to casein, which you can flavor that out. It's not too bad, but egg can be real rough to have it taste like anything that's not sadness. Collagen itself naturally is very clumpy, so it mixes very poorly, but it is a protein source that can be a pretty decent shot. Group 4, whenever you guys are ready, go ahead and share with whatever you guys came up with.
So we went with like protein and beans as our plant-based protein. And it's good because it has fiber in it. So it helps with like a lot more than just getting protein in your diet. And you obviously need a little more of it because it doesn't have as much as like plant-based protein does. Or as much as meat protein does. What else did I cover? It's helpful because anyone pretty much can have it, like whether you're vegan vegetarian, whatever. So that's all I got on it. I don't know.
Okay. Yeah, no worries. The only issue you might have with some of your vegetable-based proteins is the fact that it can be higher in fiber load, which if you're doing a lot of it and you're adding it in rapidly, it might be very hard for someone to deal with. The other component is, yes, it has a little bit lower leucine, specifically when we're talking about hemp and pea compared to soy, and they'll sometimes fortify it with that individual amino acid, as we're going to talk about leucine in a second. And exactly, if you got someone that happens to be vegan, vegetarian, or otherwise, congratulations, we got a protein powder that's going to work for them. And especially specifically, if you got somebody that is like a vegan bodybuilder, otherwise, it's going to be very difficult in order to actually not necessarily get enough protein, but if we're on a hard cut, so we naturally have to cut back on things like carbs and fats, you're going to typically be looking at some type of supplemental form of protein, because it's going to be much more difficult to not go over or go under on your protein while you're getting your calorie needs met, but that's going to cause more of a loss of lean mass as you're leaning up than what you're really looking for to try to do. Okay. Now, leucine, remember, is one of our essential amino acids. Specifically, it is one of the branch chain amino acids, one that has the greatest effect on actually signaling for a greater amount of essentially muscle anabolism. By activating mTOR, you're effectively turning on the motors of the machine, so it's going to start building things. Just because the machine's on doesn't mean you got enough of all the other essential amino acids and you have enough fuel in the cell, thanks to having enough energy in general, that you're going to build muscle, but you at least have the machine on. So like anything else, we want to make sure that we're getting in enough of it, specifically foods that are higher in it. And that's where you see our whey, soy, casein, as well as our meat sources are going to be naturally very high in leucine because it happens to be naturally much higher. And by the trigger, meaning you need to take enough of it that you get this spike in blood levels, so you're going to have those increases in protein synthesis, is about 3 grams. So all of our others, when it comes to increases in ergogenic aid, that all of them are pretty much overhyped. Glutamine hasn't been really shown to increase muscle synthesis or otherwise, might have a little bit of effects on decreasing soreness, as well as improving or having better function of the immune system, but it hasn't really been seen to have enough efficacy that it's worth the money. And then taurine is useful in the fact of it actually does seem to potentially have some positive effects on decreasing cramping, as well as tyrosine and tryptophan. Remember, those are precursors to different, essentially both of hormones and neurotransmitters. Tyrosine, you'll see it in a lot of pre-workouts because it's going to have a positive effect on essentially epinephrine production. So sometimes it's going to help you bring a little bit more heat to your training. Now, let's talk about trying to get as swole as possible, because that's the only reason anyone is here, and that's to get jacked or die trying. So we need to train in the first place. Training in turn is going to increase our muscle synthesis rates for about 24 to 48 hours. So during that time, we want to make sure that we're taking in that protein meal relatively shortly after our training, and then still regular intervals throughout the day. So we're getting in that, middle of the range, 1.6 to 1.7 grams per kg per day. We can trend that upwards if we're dealing with something that's really big and really lean. Now, we also want to do that larger dose pre-bed, so that way we're going to keep up our overnight protein synthesis and allow us to adapt at an even higher rate. Now, you want to pick something that's going to be tolerated by the person's GI, that they're going to feel good, they're not going to be having issues with bloating or otherwise. So that's why you see folks doing things like a case of protein shake pre-bed as a means so that they're going to be able to optimize this. Now, if we're trying to really maximize hypertrophy, we want to make sure we're lifting weights. We want to obviously be doing progressive overload, so we're forcing ourselves to get stronger, and lifting things so we're getting to pretty close to concentric failure. We want to make sure we're getting in enough energy. If not, we are in a positive energy balance, meaning this would be something where we're bulking. And then when we talk about being post-exercise, we have the 3 R's: rehydrate, restore glycogen, repair our muscle fibers, and remodel, so we're going to get adaptation and be ready to go again. Now, when it comes to the dangers of high amounts of protein intake, it's not really a risk. The big issue with essentially high protein diets and potentially injuring someone's kidneys or otherwise, I'm sure you guys have heard that before, and there's a number of research articles by Jose Antonio and his group out of Nova in Florida, where effectively individuals took in high protein diets. They had no issues with changes in bone mineral density, no issues in kidney health, no other negative effects on any major health outcomes. Now, a high protein diet in someone that has renal failure is dangerous. That is a horrible choice, but they have renal failure. That's the real concern. So we're not really worried about people using really high protein intakes. In fact, I've gotten to hear him speak a couple times, and one of the more recent studies he did, which was interesting, is he had folks taking 4 grams of protein per kilogram of body mass per day, didn't actually cause any positive changes in lean mass compared to the control group. So it's like they gained more muscle, but same thing, they didn't have any negative health outcomes for going super high in protein. They weren't having any major issues. What is pretty funny though, is he got one of the female figure competitors who was in his cohort to take in, he's like, just see how much you can do per day. She got up to she did 700 and like almost 50 grams of protein in one day as a 130-pound female. Then there was a guy who literally did a full 1,000 grams of protein in one day. It was a lot of sad plain chicken as well as protein shakes. And I don't even want to think about how bad, how to say, the type of wrath they took upon their toilet the next day. So I'm not worried about high protein intake. Taking in larger boluses is not really that dangerous. The key thing is, are we trying to optimize? Are we eating due to our palate? What are we really looking for here, guys? So any questions on health risk with protein? Anything you guys would like me to go and talk about? Because I'm sure someone along the lines has told you guys that, you know, high protein diets are going to kill your kidneys or otherwise, and I would like to effectively nip that in the bud right here and now.
Do people just say that because of that it's hard for people who already have renal failure, or are they just uninformed?
It's an extrapolation from disease populations. That's really how it initially happened. Is it was folks that happened to be diseased. They found that, yeah, if you have renal failure and you go higher protein, you'll kill yourself. And then unfortunately, then it got extrapolated to it's going to kill everybody. So it's just misinformation and dogma. It happens on all sides, as well as the thing. Whenever I was your guys' age, I was taught vehemently by a number of people that were not very strong and not very muscular, that anything over 30 grams of protein in a meal was wasted. And that's just not true. The reality is, yes, you might actually get more out of a higher protein intake, especially if you're a larger human. And it's one of those things. That's why you see it's like gram per kilogram of body mass, then also thinking per gram per kilogram of lean mass. So when we're giving protein recommendations, it's really important. We know how big a person is. We know what their goals are. We know what are we really trying to accomplish. And protein is actually the most important as far as increasing it when we're actually trying to get somebody to lose weight. That's when we actually have the highest demands, because we're trying to effectively keep the body to have as much of a synthesis going on inside of those tissues to avoid the greater catabolism that's obviously happening in the fat cells, hopefully more so than any other tissue type. So any questions on protein and health?
I have a question.
Yeah, what's up?
So we're kind of talking a little bit about like protein and carb intake in strength and conditioning. And Dr. Larkin said that excess protein can like eventually turn into fat. How or like why does it do that?
Works. I'm not concerned about saying what I'm saying and demeaning anyone. You might want to go ahead and do a bolus of, if you're doing enough protein in general, your body's going to strip that down into its individual amino acids, and then it can convert from the essential amino acids and whatever it needs. The reason animal-based protein is good for people that are lifting weights, because it turns out the most animal meat is damn near the exact same amino acid concentration that your muscle's made out of. So it's easier to interconvert. Whereas collagen is the connective tissue of animals, so it has more of hydroxyproline, proline, and I believe lysine are going to be the 3 amino acids that you have in a higher percentage in connective tissue. And because you're eating that in collagen, you in turn are going to have a little bit of an advantage. And if you get 1% better per day because you're doing collagen protein over just normal protein, sort of, animal protein, plant protein, that 1%, it can mean a decent amount if you do it every single day. It might not really make that big of a difference for you. The key is, like anything else, you need to think about, is that investment worth your time and energy? So good questions, guys. Anytime, right? I don't like sitting in a room talking to myself. I hope you guys enjoyed laugh at the wonderful headgear I was wearing. And also the EOD suit is now in the lab. So we're gonna be doing some pilot work on it and then doing some research. If any of you guys are interested in coming by, getting to put on the full thing and getting to do some physical activity, let me know. All right, last activity for you guys. You are going to be breaking down, okay, the protein for these athletes over a given day. So notice, guys, we're going to break it down into a variety of different meals. Just want to have you guys say, okay, this is how many ounces of this type of food, this many milliliters of milk, etc. Try not to do it through protein powders. Try to do it through whole food sources. And notice, guys, each of these is going to be 4 meals. So we're trying to essentially do it in 50-gram boluses and go from there. Questions, comments, concerns before I send you guys out. And you're going to give us, obviously, what product, total amount of protein, and then calories that they're going to be getting from what they're taking in. Questions? All right. The rooms are open. Whenever you guys are ready, go ahead and hop inside. And then obviously be ready to come back at 6:56, probably a couple minutes after 7. We'll go ahead and obviously work through what you guys came up with. Okay, so first thing we'll go ahead and do is obviously break through what Tyler's group came up with. And so, that's a dry rice. Sounds like such an appealing lunch, but it's obviously something you can do. That is a whole lot of beans and rice again. And then we do some cream wheat and then a little bit of toast and we get out the rest of it. So nice work. Man, that's a lot of rice and beans. So they're gonna do some work the next day. Cass's group, that's okay. Nice. So yeah, you're struggling to get in enough protein whenever you're specifically working with someone that's vegan relative to the amount of calories we're taking in. Now, obviously, there's a lot of nutrient dense foods, like you're making good choices, but like anything else, we're limited on how much we can do. And then Celia's group. Nice. Now, how many crab legs and how many shrimp are we talking about? And we say the size of a salmon fillet and a tilapia fillet, how big are those? And Colleen, great job on the carnivore. That definitely looks like it would be something to maybe try once or twice, but boy, howdy, that's a lot of protein with a lot of animal sources with a lack of fiber. So I imagine getting back to how regular someone is, that would be a bit of a challenge. Thank you, Josh. Is that about the same for I guess the salmon, I imagine would be like a 12-ounce fillet, then if it's going to scale about the same. Okay. And then crab legs, in order to get the 20 grams in the shrimp, about how much would that be? Nice. Living the dream. That's what Shrimp Fest is there for, whenever Red Lobster does that. Now, as far as group one, how are you guys doing? You guys just want to go ahead and unmute and we can talk through what you guys have.
So I was still looking at breakfast. I know Kodak Cakes has a plant-based like kind of protein of like their pancake mix, and I know it's 12 grams per serving. So we could add some of that in there. And then for dinner, I mean, I guess it would be boring, but they could add in more tofu, and then like there's snacks that they could add like nuts and stuff throughout the day.
Yeah, you'll get in enough, no questions asked. I mean, peanut butter has, you know, a bit of protein in there, as obviously, as well as a lot of calories from fat, and depending on if it's natural or it's, you know, more of your typical store-bought where they add in a decent amount of sugar, you know, you're getting a lot of calories in general. So your guys hands down was the hardest one, because if you're doing protein powder for any of these, it makes it really easy. But if we're doing whole food sources, the carnivore diet's easy. That's pretty much what they're doing the entire time by eating animal sources. The lacto-vegetarian, they can do dairy, they can do eggs, takes care of itself as well. Now, the pescatarian, we're talking about, we're able to do effectively seafood. So same thing, we've got a lot of different protein sources, but the vegan vegetarian athletes are going to be the ones that might have a bit more issues. But notice, this is a lot of protein. Taking in 200 grams of protein per day is a pretty solid amount, unless you're really trying to lift weights and be, you know, pretty strong and you're a bigger person in the first place. Very few people ever need to take in this amount per day. But this was a thought exercise, make you guys go through it and kind of see what you came up with. Does anyone else have any questions, comments, concerns? Otherwise, we are going to bid it adieu, and we are going to be talking about the joys of hydration and hydration strategies next week. Any questions, comments, concerns before you guys get going? All right, guys, whenever you're ready, head on out. Have yourselves a great night.